Hello friends, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about weights rule. So, I will discuss in this video introductions of boranes, diborane, types of boranes, bonding and structure in boranes, carboranes, types of carboranes, weight rule and applications. So, introductions. The binary compounds of boron and hydrogen are called boranes. Boranes were first prepared between 1912 and 1936 by Alfred Stock, who developed vacuum line techniques to handle these relative materials. Borane are the name to class of synthetic hydrates of boron. The molecules of these compounds are electron deficient and so reactive with respect to electron donors. Many boranes synthesize from thermolysis of diborane, and all boranes are diamagnetic and colorless. Now friends, boranes. The parent member BH3 is called borane. It is found only in the gaseous state and dimerizes to form diborane B2S6. General formula of borane is BXNHY. The most important boranes are diborane B2S6, pentaborane B5H9 and decaborane B10H14. Boranes are all colorless and diamagnetic and some are pyrophoric. Boranes are highly reactive. Common reactions with boranes are electrophilic substitution, nucleophilic substitution by Lewis bases, deprotonations by strong bases, cluster building reactions with borohydrides, and reactions of nidoboranes with an alkyne to give a carborane cluster. Now friend, diborane. Diborane is simplest and most studies of boranes. It is an electron deficient molecule. It has less number of valence electron than the number required to form all the electron pair bond. In its structure, 2 hydrogen bridges are present. You can see in this picture. The model determined by MOT indicates that the bond between boron and terminal hydrogen atom are conventional 2-center 2 electrons bond. Having used 2 electrons in bonding to terminal hydrogen atoms, each boron has 1 valence electron remain for additional bonding. The bridging hydrogens provides an electron each. The B2S2 ring is held together by 4 electrons. Now friends, bonding and structure in diboranes. The diborane molecule has 2 types of bond, 4 terminal 2-center 2 electron BH bond, 2 bridge 3-centered 2 electrons BHB bonds. Now 4 terminal 2-centered 2 electrons BH bond. Each of these bonds are formed by sharing of 2 electrons between boron and terminal hydrogen atom. It is a normal sigma covalent bond. 2 bridge 3-centered 2 electron BHB bonds. Each of these bonds is formed by sharing of 2 electrons between 2 boron and 1 hydrogen atom. It is also called as banana bond. Now types of boranes. Closoboranes. Closed triangulated polyhedra structure and all corners of triangulated polyhedra are occupied. General formula BnHn plus 2. An example B6S6 2 minus. This is octahedral. Each corner CBH. Now nidoboranes. Nidoboranes are formed when one corner of the polyhedra is removed. Nest-like non-closed structure. General formula BnH2n plus 4. For example, B5H9, B2H6. Now friend, arachnoboranes. These boranes are formed when two corners of the polyhedra is removed. Wave-like non-closed polyhedra structure. General formula BnHn plus 6, B4H10. Now hypoborane. Hypo means net-like. These have most open cluster in which boron atoms occupy n corners of n plus 3 polyhedron. General formula BnHn plus 8. These boranes are having complex structure. So B8H16, B10H18. Conjunctoboranes. These boranes formed by linking of two or more of any other types of boranes, and these structures are very complex. General formula BnHm, example B5H9 whole 2, B4H10 whole 2. Now bonding in boranes. 2 center 2 electrons bond BH, 3 center 2 electrons bond BHB, BHB. So in boranes, 4 types of bonds are present. 3 center 2 electrons BHB, bent. 3 center 2 electrons BBB, open, and closed BBB. Third, 2 center 2 electrons BB, normal. 2 center 2 electrons BH, normal. Now Stix codes, STYX, Stix codes. The overall boranes bonding can be represented by 4 digital numbers. S number of BHB bonds, first digit. T number of BBB bonds, second digit. Y number of BB bonds, third digit. X number of BH bond groups, BH2 groups, fourth digit. So B2H6 diborane, S number of BHB bond 2, T number of BB bond 0, Y number of BB bond 0, X number of BH2 bonds 2. So hence the for diborane Stix code is 2002. Example B4H10 Stix code is 4012. Now friends, carboranes. Carbonanes are mixed hydride of boron and carbon in which carbon and boron atoms occupy the vertices of triangular polyhedra. Carbonanes are most important heteroboranes. Carbonanes are member of a class of organometallic compounds containing carbon, borons, and hydrogens. General formula of carbonanes is C2BnHn plus m, where n is an integer. Carbonanes with n ranging from 3 to 10 have been characterized. Boranes and carbonanes have same number of electrons in their bonding framework, will have similar structure. Now types of carbonanes. Closocarbonanes. Closed triangulated polyhedra structure. General formula C2BnHn plus 2. Total number of electrons in bonding framework is 4n plus 2 electrons, that is n plus 1 electron pairs. Now nidocarbonanes. One corner of triangulated polyhedra is removed. General formula C2BnHn plus 4. Total number of electrons in bonding framework is 4n plus 2n plus 4 electrons, that is n plus 2 electrons pair. Example C2B4H8, like that. So BH and CH. Arachnocarbonanes. Two corner of triangulated polyhedron is removed. General formula Total number of electrons in bonding framework n plus 4 electron pairs. For example, 13C2B7S13. Now friends, Wade's rule. In chemistry, polyhedron or polyhedral skeleton electrons pair theory provides electrons containing rules useful for predicting structure of boranes and carbonanes. It is formulated by Wade's and hence it is called Wade's rule. In Wade's rule, each BH unit donates 2 electrons to a skeleton structure. Each CH unit donates 3 electrons. So negative charge on boranes give an electrons. Additional hydrogen atoms give 1 electrons each. So closo n plus 1, nido n plus 2, arachno n plus 3 and hypo n plus 4. For example, this. Now application of boranes and carbonanes. Boranes are used as rocket fuel in supersonic aeroplanes, used as catalyst in polymerization reactions, used as a reducing agent in organic reactions. Boranes can be used as vulcanizing agent for natural and synthetic rubber, used in borane coating. So conclusions. Boranes are colorless and gaseous at room temperature. Boranes are highly reactive and reacts violently with water. In boranes, 3 center 2 electrons are present. It is unique type of bonds present in boranes only. Carbonanes are mixed hydride of boranes and carbon and have the same structure like boranes, and carbonanes derived from pyrolysis of boranes. So friends, these are reference. So if you like this video, then subscribe my channel, and thanks for watching.